Why does a heat pump that only draws 9 amps while running spike to over 200 amps when it starts? That's because when your air conditioner first kicks on, the compressor motor tries to go from a dead stop to full speed instantly, and that surge of electricity can be 4 to 5 times higher than normal running current. That massive surge was causing my lights to flicker every time the compressor kicked on. So I did what most people do. I bought one of these hard start capacitors thinking that it would fix the problem, and it didn't. That sent me down a rabbit hole buying and testing multiple solutions that claim to reduce AC compressor startup current. Why? So you don't have to. In this video, I'm going to compare 3 different options, show you how to wire each one of them, and prove which ones actually work using real startup current measurement. I'll test them on normal utility power and on generator and off-grid power solutions where startup surge really matters. One of these worked incredibly well, one barely worked at all, and one actually blew up. If you've ever tried to run an air conditioner on a generator or solar inverter system and had it overload when the compressor started, this video will save you time and money. Welcome back to Projects with Everyday Dave. Let's get started. I love actual testing because there are always results that I did not expect. In this case, I did a lot of testing, and I don't want this to be a long video, so I've included chapters down below for each solution I tested. You can jump right to it. I'll show you how to install each one of these units, and then I'll show you any unusual tests that I ran into. I'll summarize all the results at the end for your convenience. I'll compare all of them to a baseline result on grid-connected mains power, and for accuracy, I've averaged at least 4 startups in most cases since some of these devices have a learning capability and improve with multiple startups. I'll show you the startup performance for my 4-ton compressor for each of the following off-grid solutions: a budget 3 kilowatt generator, the budget Pecron 7 kilowatt power station, the 6 kilowatt Anchor power station, and a powerful whole home solar inverter, the EG4 FlexBoss 21, which can deliver 12 kilowatts of power on battery backup. I've set my meter to inrush. Now I'm testing startup on mains only, no soft start. All right, it's getting ready. Circulation pump kicked on. Start it up. So you hear that kind of hard start sound? Now you can see the inrush current was 133 amps and the peak was 225 amps. That is really high. Now if I just measure the current draw while it's running, we're at 9.8 amps, 60 hertz, just under 10 amps to run continuously. All right, let's see if my FlexBoss 21 can start this compressor without a soft start. Okay, here it goes. Okay, it did it. Didn't sound super excited about it. Looks like 98 amps at startup and 144 peak amps. So it would have really struggled there. The voltage probably dropped quite a bit. And running, we're at 10 amps, 60 hertz, running smoothly. As you can see from this chart, only the direct grid connection and the 12 kilowatt FlexBoss 21 were able to start the 4-ton compressor in its stock configuration. I averaged 5 startups on grid power for the result in this table, and the result did not fluctuate very much. The gas generator and both solar power stations have insufficient margin to get the job done. It's time for some help. Before wiring, make sure the breaker's off. There should also be a disconnect right near your unit. Open the lid, pull the handle. Then you can use a meter to confirm that there is no voltage. To remove any chance of electric shock, you can short out the capacitor by crossing these 2 posts with a screwdriver, just to make sure that you don't accidentally get shocked. And then you can use some high voltage rubber lined gloves for just a little extra protection. I can't show the results for this one since the capacitor blew up. It was a prototype, so I won't disparage the developer. Instead, we're going to start with this very low-cost, budget $30 hard start capacitor. The hard start kit is the easiest of all to install. Before you start, pull the disconnect on your AC unit and use a metal device like a screwdriver to touch across the capacitor and make sure it's discharged. You can do that with this one as well. Of course, it shouldn't be charged, but just for good measure. Identify the start winding, which is connected to your compressor. You can look at your wiring diagram. It'll be the wire connected to the capacitor. you want the yellow wire from the start relay to be connected to the start winding side of your capacitor, and then the red wire off of your capacitor to be connected to the line 2 or T2 side of the capacitor. And then finally the black wire just goes to the remaining input power. In my case L1, could be T1, but it will also be the same as the C winding on your compressor. And usually there's extra lugs there to connect to, so we can just shove that on. There we go. Then you can mount these somewhere within your unit to keep them away from contact. And that's all there is to it. I'm not putting it in right now. I'm just going to show you the performance of it. Okay, it's all set up. Now let's see if it works. Generator test with hard start. That is not working. I'm gonna have to pull it. Ooh, that was bad. Okay, we got to 31 amps and 84 amps peak, but it was just loading down the generator. The generator didn't die and the compressor didn't start. That is a really bad situation. Pecron test with hard start capacitor. Oh, overload. Did not make it. We got to 38 amps, 77 amps peak, but we have an overload. Sees it as a short circuit. Anchor Solix with hard start. Ooh, fail. Overload. Wow. Tried pretty hard. 44 amps inrush, 65 amps peak. Not enough. Well, this thing was all around disappointing. No wonder it didn't help with my light flickering problem. The inrush and peak amps with grid power were almost exactly the same as with the capacitor, and the 12 kilowatt inverter, they were actually worse. So obviously the gas generator and both solar power stations had no hope of starting it with the hard start capacitor. You might be wondering if this is just a scam product. The reality is it's not designed to reduce inrush current. It's designed to give a boost to the start winding for weak and struggling compressors. And that's just not our objective here. It's time to see if performance can be improved by spending more money. Let's install the Soft Start Home and do the testing on it. At the time of the recording, it was available on Amazon for $380. Let's start by disconnecting the power and discharging the capacitor just like before. Wiring diagrams for these are almost all entirely the same. There will be a line 1 and line 2 going to the compressor, and then usually a blue or other colored wire going to the capacitor, and from the capacitor to line 2 in my case. It has 5 wires. The red and black will go to line 1 and line 2. The brown and blue will go to the 2 legs of the compressor, and then the yellow will go to the capacitor. In some cases, your wires may already have a spade on them, like this one that I've added the spade to. They may be on a ring terminal like this one. In this case, the kit comes with all the connectors you'll need to install the system, including a little bit of shrink tube to cover up the joints and some zip ties to hold it in place. And you'll need a set of crimpers in order to utilize them. These are pretty expensive. If you want to do any of this kind of crimping, you'll need them. We'll use the yellow setting. I'll link to these in the description below if you need to get a set. So I can just cut off the connector that came on the unit, rip some insulation, we'll slide on the new spade connector and crimp that down. There we go. We'll start with the main power connections. The black wire is going to go to the same line as the capacitor is connected to. In this case, for me, the capacitor is connected to line 2, so I'm going to connect black to line 2. Then the red power wire will go to the other side, line 1. Make sure they're good and tight. Now I have the blue and brown wires. I don't want these joints exposed, so before I put them together, I'll just grab that piece of shrink tube that was in the container and slide it on the wire. I'll connect the blue to the red and slide another piece of shrink tube on the black wire, and then the brown connects to the black. Now I'll be able to just heat shrink that on there, and then I'll tape the joint up. Okay, and then our final wire is the yellow. This is the line side of the capacitor. This is the compressor side, so we just connect that guy there. And that's all there is to it. Now in my case, this isn't outdoors. If it was outdoors, I'd want to make sure and mount this vertically so that water wouldn't go up in this hole. And the other version I'll show you of these soft starters has a little better seal than this one. In my case though, I have plenty of space in here and water's not a concern, so I'm just going to mount this right there. And then I can zip tie up all the wire. There's a wiring diagram for all kinds of brands on the website. If you have something that looks different You can check it out, but they're all pretty similar. All right, time to check soft start on mains power. All right, there we go. 28 amps, the peak of 59, and current draw is 9.4 amps, just about the same as before. All right, soft start with an inverter, battery supply only. Let's see what happens. Wow, that was smooth. Look at that, 23 amps. That is amazing. Just in case you forgot, here's what it sounds like without the soft start. What a huge difference. Soft start home on generator power. Nice. It did it. Look at that. 18 amps of inrush, 44 amps peak. Perfect. Anker Solex with soft start home. Woohoo! It did it. Nice. 24.5 amps inrush, 52.6 amps peak. Nice. Soft start home on Pecron power. Oh, almost, but not quite. This time it was the inverter that overloaded, so the system didn't stop it in time. It got to 26 amps, 57.1. Just not quite enough. The Easy Start Flex is really easy to install. There's only 4 wires to deal with, and they have Wago connectors, which makes it so you don't have to even have a crimp tool. Look at the wiring diagram. There's a S, C, and an R on your compressor. If you don't know which wires they are, you can look at the wiring diagram or the side of the motor, like mine usually will tell you which is which. In my case, the red wire is the run wire, the R. And it's also easy to identify because it's usually connected to the same line side as the capacitor. So the same connection point that the capacitor and the run wire are connected to, all I need to do is cut that one and strip it. And the white and brown are just breaking that connection. The white one is going to connect to the neutral post. That should be tight. You shouldn't be able to pull it out. And then the brown wire will connect to the other end, which goes to the R line on the compressor. Okay, there's a label right on it. Connect this wire only to the run winding. So that just breaks the power to that one winding on the compressor. Line goes into the unit, then back out to that one line. Now the remaining 2 wires bring power to this unit. The black one will connect to line 1, which is the other input. Usually there's just a spade to connect there. And then the orange one will connect to the capacitor, in this case the compressor side or the start winding side of the capacitor. The charged side will stay connected to line 2. And that's all there is to it. Break the one, connect to the capacitor, connect to the line, and it's all wired up. Now I have a nice clean spot where I can mount mine. So I'll go ahead and mount that, and then we'll test it. Easy start, mains power, test 1. That's pretty good. 19.8 amps in rush and 121 amps peak. The results table don't exactly match the meter because they're an average of 4 or more test results. The Easy Start Flex is a learning soft start, so I had to take at least 4 measurements with each input to get a stable result. From the 5 measurements shown, you can see rapid improvement after the first run. For the rest of the Easy Start results, I'll just show the average in the table. Okay, generator with Easy Start Flex. Ho ho ho! It did it! Check it out. 18.2 amps, 50 amps peak on a 3,000 watt generator. That is magic. Anker Solex with the Easy Start Flex. Wow, that was really good. It's only 14.6 amps with a peak of 34 amps. This thing is amazing. Pecron with the Easy Start Flex. Ooh, didn't do it. And it didn't shut off the Pecron either. Well, 15.5 amps, 43 peak. Just wasn't enough. Let's see what the Bluetooth says. Looks like we had a fault, power interruption fault, so it decided not to start the unit. Wow, it is not often you get results this dramatic. This graph shows the peak amps at startup for each configuration. Far left is the stock setup, averaging 178 peak amps. Only direct grid power and the 12 kilowatt FlexBoss 21 inverter could start the compressor with the stock configuration. What's funny is the hard start was actually the same or worse, averaging 202 peak amps. It might help a weak compressor get started, but it does nothing to reduce the input load. Then we see a dramatic reduction with the soft start systems. The soft start home had an average peak starting current of only 51 amps. That's why I was able to start it with my budget 3 kilowatt generator and the 6 kilowatt Anchor solar power station. The Easy Start Flex was slightly better at 42 average peak amps. It seemed to do a little better job learning and adapting to each one of the systems. Even though the Pecron is a 7 kilowatt inverter, it couldn't start the compressor, likely because the software is conservatively programmed, telling it to cut out under high loads. Finally, they both work amazingly well, and it really comes down to price and features. At the time of this recording, the Soft Start Home is $380 on Amazon. You can purchase the Soft Start Home and the Anchor Solix Power Station from Signature Solar, where you can get a $50 discount on purchases of $500 or more using my link and the exclusive code in the description below. If you're bundling other solar equipment, that could help you out. You can also find additional discounts and everything you need to know for going solar on my website, projectswithdave.com. I don't have any additional discounts for the Easy Start Flex, but if I do get one in the future, I'll add it to the description below and on my website. The Easy Start Flex has the edge with the overall best reduction in starting amps. Like other soft starts, it can support up to a 6-ton compressor and make it possible to start your AC with generators and solar inverters. It also reduces compressor wear. What sets it apart is its ability to stop the compressor from even starting if there's insufficient power, which we saw in one of our tests. That could protect other electronics in your home from getting damaged. It has flexible and resettable learning modes, and Bluetooth settings and diagnostics. If your AC compressor is mounted outside, the Easy Start Flex has a better seal on the cord. If the price is the same, the Easy Start Flex has an advantage in pretty much every area. That being said, if you can get a deal on the Soft Start Home, they basically have the same performance. I'll leave links to the tools and all the options in the description below. If you want to go solar or off-grid, be sure to check out my website, projectswithdave.com. for free educational resources. If you want to know more about going solar, watch this video series right here. If you want a detailed breakdown on the Anchor Solix Power Station and everything it can and cannot do, watch this video right here. Thanks for watching, and I'll see you next time.